Hello everybody, I can prepare for my area volume test by practicing. So let's go. Volume, you need to know your volume formulas. If you don't know your volume formulas, this test is not going to go very well. Volume equals length times width times height, and pi r squared height. There's 3 length times width times heights. There's 2 pi r squared heights. Rectangular prism is length times width times height. Triangular prism, 1/2 is for triangle, 1/3 pyramid and cone. That's your formulas. Once you have them, you have them. If you don't have them, you're going to have a bad day. The one that is given to you is your sphere, and that is 4/3 pi r cubed. That is given to you. The rest of them are not. So again, the song helps. It's either length times width times height or pi r squared height. Triangular prism is 1/2. Cone and pyramid is 1/3. So if it wants a regular pyramid with a square base, well, pyramid is 1/3 length times width times height. Write it out on your test. Once you write it out, you have it. The twist here, if it's a square base, the length and the width are both 14. The altitude is 24. Altitude is the height. That's what you want. If it gave you the slant height, which we'll see later in this review, then you'd have to do Pythagorean theorem first. 14 times 14 times 24. You pop it into the calculator and you're done. 1/3, 14, 14, 24, 1568. I gave you different shapes here. I'm not going to go over every single shape. We'll incorporate some of them into other types of problems. Here I have a triangular prism. Well, triangular prism is 1/2 length times width times height. The length and the width, do the length and the width of the rectangle, and then the height is straight up from there. That would be the 4. The 5 is the slant height. That is not the length, the width, or the height. 1/2, 8 times 3 times 4. Use a calculator if you need to. I believe that is 48 cubic centimeters. So for the triangular prism, for the length, width, and height, think of the length and width as the rectangle's length and width, and the height straight up from there. Compound shapes. Let's just do this one. You find the volume of each individual shape and you add them together. So here I have a cylinder and I have a hemisphere, or 1/2 of a sphere. Cylinder is pi r squared h. Hemisphere, since it's 1/2 of a shape, it's 1/2. 4/3 pi r cubed. The radius is 1/2 of the diameter. You can use a calculator if you need to. 1/2 of 8.3 is 4.15. The height of the cylinder is 10.2. The hemisphere has the same radius, 4.15 cubed. We type it in. Pi 4.15 squared times, what was it, 10.2? Yup. Is, oh, I'm sorry, it's a, oh, that's not a cylinder. Wow, that's a cone. It's 1/3. So I can just copy and paste that times 1/3. Doesn't matter where the third goes. I got 183 dot dot dot. The hemisphere, I've got 1/2, 4/3 pi 4.15 cubed, 149 dot dot dot, add them together, 183 plus 149. I believe it's said to round to the nearest tenth, so I'm looking at 333.7 cubic centimeters. So if I have a compound shape, a shape that is made up of multiple shapes, find the volume of each shape, add them together, and again, whenever you're finding the volume, you're referring to this list that you're creating at the beginning of the exam. Just talking about this one here, I could do it, but what shapes make up this shape? Well, I see a rectangular prism, length times width times height, and then on top of that, I see half of a cylinder. So I'm going to do the cylinder formula with a half in front, half pi r squared h. Cross-section is a cross-section is a two-dimensional slice of a three-dimensional object. Perpendicular is vertical. Parallel would be horizontal. For any prism, vertical is going to be a rectangle, and horizontal is going to be the base, whatever the base is, for a prism or a cylinder, that is. And then if you have a pyramid or a cone, vertical is going to be a triangle, and then horizontal is going to be the base. So it's kind of a little cheat sheet here. And again, vertical meaning perpendicular, horizontal meaning parallel. So here it wants perpendicular to a hexagonal prism. That is a rectangle. If it said parallel, then it would be hexagon. And if you want more help with cross sections, watch the cross section video where I bust out the Play-Doh and do all that. 3D rotations. It wants me to rotate this thing around MH. So I reflect it over MH, and then I connect with curves. I have a cone. Volume of a cone is 1/3 pi r squared h. Again, just refer to the list that you've created. The radius of this cone is 8. The height is 5. Yes, it matters which one is the radius and which one is the height. Nearest tenth means type pi in. 1/3 pi 8 squared 5, 335.1. So for 3D rotations, you start by reflecting it in 2 dimensions, connect the original and the image with curves. It always has to be a circular shape, whether it's a cone, a cylinder, or a sphere, or a hemisphere. It has to be something rounded because it goes in a circular motion. And once you have that, you can find the volume the same way as everything else. Volume with algebra. It's giving us that the volume is 288 of a pyramid. So I start by writing the volume of a pyramid formula. If it's telling you the volume is 288, replace V with 288. Width is 6, length is 8, and we're trying to find the height. I said it before, I'll say it again. I don't care if you're the weakest student or the strongest honor student. I don't trust your algebra. Use the equation solver. Math up, enter, type the left-hand side in. Really got to make this calculator fit better. 288. Type in the right-hand side, 1/3, 8 times 6 times x. Okay, solve, 18. There's a typo in this question. I believe I fixed it in your packet. 18. If we're doing the algebra, this one's not bad. I'll do the algebra. 1/3 times 6 times 8 is 16h. Divide by 16, divide by 16, and I get 18 equals h. And yes, on this one, the algebra is not bad, but with cylinders, we have dividing by pi and everything else, and roots and all that. As far as geometry goes, this is a geometry course. Once you set it up, I would make sure you just use the equation solver to get the right answer. Do it algebraically, absolutely, but definitely check it in the equation solver. Don't lose points because you can't solve the algebra. I've had students who've gotten a 64 because they can't solve a basic 7th grade equation. If they would have just used the equation solver, they would have passed. Density. Density is mass over volume. So we start by finding the volume. It's a brick. Brick is like a rectangular prism, length times width times height. 4 times 3 times 8, 96 cubic centimeters. So now for density, density is mass over volume. The mass is 1824 grams over 96 cubic centimeters. Divide them, 1824 divided by 96, 1824 divided by 96 is 19. So my density is 19 grams per cubic centimeter. Density is mass over volume. Calculate the volume, put the mass over it, it will give you the mass. All right, this moves into our modeling. The first thing you need to do is check your units. Centimeters, cubic centimeters, I'm good. If I'm not, I'll have to convert first. In this case, I don't have to. I start by finding the volume. It's a cylinder, so I go pi r squared h. The diameter is 4, so the radius is 2. So it's pi 2 squared, and the height is also 2. Type pi in, unless it specifically says in terms of pi, which it really won't for the modeling stuff. Type pi in, pi 2 squared 2, 25 ... cubic centimeters. Now I take my volume and I start my dimensional analysis. Cubic centimeters on bottom. I'm looking for cubic centimeters. There it is. I'm going from cubic centimeters to ounces. 2.1 ounce for 1 cubic centimeter. Now I have ounces. I'm done with that piece of information. 14 cents per ounce. So ounce is going to money. 0.14 is the money. 1 ounce. Whenever it says per whatever, it's one of them. All right, I have my cost. There's 4 bricks, so I multiply that by 4. I go to my calculator. Alpha x. Second answer, that copies and pastes my 25. ... 2.1. 0.14. 4. On bottom, I have 1. To the nearest cent, 29.56. Find the volume, do dimensional analysis. It's not so bad if you're prepared for it, and you must check your units first. Number 17, I've got inches, I've got inches, I've got inches, I've got cubic feet. Well, that's a problem. Whatever the volume is, that's what I need my units in. So I have to convert 43 inches to feet by dividing by 12, 30 inches by dividing by 12, and 9 inches by dividing by 12. 43 over 12. We can leave it as 43 over 12. You can use the calculator to reduce these. 30 over 12 is 5 over 2, and 9 over 12 is 3 over 4. So the volume is length times width times height for a rectangular prism. So it's 43 over 12, 5 over 2, 3 over 4. Type that into the calculator. 43 over 12, 5 over 2, and 3 over 4. I get 215 over 32, and it might be a good idea to just make that into a decimal by dividing them. 6.71875 cubic feet. Now I start my dimensional analysis. 6.1875 cubic feet. Cubic feet. Each bag is cubic feet, so I'm going from cubic feet to bags. One bag is 0.5 cubic feet. I have bags. That's all I need here. It's not asking for cost or anything else, so I'm not going to multiply. I have 6.1875 over 0.5. Over 0.5. I got 13.4375. That's the number of bags, but I can't go to Home Depot and ask for 0.4375 bags, so I need 14 bags. Even if it was 13.0000001, I would still need to go up to 14. 13 is not enough, 14 is. So when it comes to bags, you always go up to the next whole number. So convert first, and you have to just read carefully. All right, if you have inches, looks good so far, but I want cubic feet. I don't have cubic feet, so I have to change that up. All right, what else do I got for you? Do I have some old stuff? Yep, I got some review, as always. We got some Hill Sash. I really hope at this point in the year you recognize this picture. That's asking for ST. There's an L involved. This is HLLASS. There's an L involved. Hills. H is the whole bottom, which is 14.3. 14.3 over x equals x over 10.2. X squared equals 14.3 times 10.2. 145.86 square root. And I get 12.1. So you'll have a Hill Sass question. You see these all the time. That's the whole point. Get it right all the time. Get it right in the regions. Everybody's happy. This one's a little trickier, but it's not. To identify transformations, to identify rigid motions, check for orientation. Check for orientation. Same rotation, state center. It's a rotation. It's basically, if it's the same, it's not a single line reflection. State, check for orientation. Different one-line reflection. That's the answer to the problem. Check the orientation. For a multiple choice question, there can be multiple choice or open response. On your exam now, it'll be multiple choice. If it's the same, it's not a single line reflection. It could be a double line reflection, it could be a point reflection, it could be a rotation, it could be a lot of different things, but I know if the orientation is the same, it's not a single line reflection, and if the orientation is different, it must be a single line reflection. And again, be careful, don't confuse line reflection with point reflection. So we check for orientation. GIA is going counterclockwise. JET is going clockwise. The orientation's different, so it must be a single line reflection. Point reflection, translation. That's not a single line reflection. That's zero line reflections. Reflection over the y-axis, translation one down. Yes, that's a single line reflection. Rotation 90, translation. Nope, there's no line reflections. Reflection over x equals 1, that's a line reflection. Reflection over the x-axis, that's a double line reflection. Nope, it must be a single line reflection. And that's it. I don't have to do anything. I don't have to even look at the grid as far as after I check for orientation. If the orientation is different, it must be a single line reflection. If the orientation is the same, it can't be a single line reflection. That's what you need to get that question right. And I think that's it. Nope. Oh yeah, we got our area. To find our area on the grid, box method. We draw a box around our shape. I did a pretty good job with that box. I'm pretty proud of that. Let's count everything up. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I find the area of the rectangle. That's length times width. That is 11 times 12. That is 132. Use a calculator if you need to. Now I find the area of the triangles. Triangles, half length times width. So let's start with this one here. The length and width are 3 and 11, or base and height, whatever you want to call it. Half times 11 times 3 is 16.5, or your calculator might have given you 33 over 2. Either way is fine. Area of triangle 2 is half 9 times 7. That is 31.5. Area of triangle 3 is 12 and 4. Half 12 times 4, which is 24. Now I add up my triangle areas. That is time for me to use the calculator. 16.5 plus 31.5 plus 24, 72. I now take my rectangle area, 132, and I subtract the area of all the triangles, and that leaves me with 60. So basically the concept here is I'm finding the area of the rectangle, and then I'm subtracting all of those outside triangles, and that leaves me with the shape I'm trying to find. If it's a triangle, there'll be 3 outside triangles. If it's a quadrilateral, there'll be 4, and that's it. And finally, area of a non-right triangle. Triangle area, half A, B sine C. Half A, B sine C. That's your formula, where A and B are sides and angle C is the included angle. We need 2 sides in the included angle. So if the angle that I have here is 38, the sides I need to use would be the 15 and the 18. It's like SAS from triangle proofs and from similar triangles. I need 2 sides in the included angle. Once I have those, I just pop them into half A, B sine C. Make sure your calculator is in degree mode. It only matters, see right now I'm not, it only matters when you're typing in anything with sine, cosine, or tangent, which basically is a trig unit, and literally this one isolated question. 1/2, 15, 18, sine 38. I don't know what it said to round to. I'm going to guess the nearest tenth, 83.1. So area of any triangle, half A, B sine C, where you have 2 sides in the included angle. The lowercase letters are your sides, the uppercase is your angle. On the grid box method, review. If you want to identify transformations, check for orientation, the order of the letters. If it's different, it must be a single line reflection. If it's the same, it can't be a single line reflection. Hill-Sass, not much to talk about there at this point. for modeling, make sure your units match. If they don't, convert first, divide by 12 to go to feet, multiply by 12 to go to inches. That's really the only conversions they ask. Once you find your volume, you do your dimensional analysis. Density is mass over volume. Find the volume first, then put the mass over it, which you will be given. If it gives you the volume, just sub into the formula like you would if you're calculating the volume. I would use the equation solver to keep it simple, or do the algebra. If you're going to do the algebra, please check it using the equation solver. 3D rotations, reflect in 2 dimensions, connect with curves, and then if it asks you to find the volume, find the volume. Cross sections, perpendicular is vertical, parallel is horizontal. We spoke about the rules there. If it's a shape made up of multiple shapes, find the volume of each individual shape and add them together. If it's half of a shape, put half in front of the formula. Triangular prism has your length and width of the rectangle is your length and width. Your height is your 4. And that's it. There's one other thing I just realized that I didn't put on here, which you should be responsible for. So I'm just going to add that in at the end here. Let's say I have a cone. In fact, you know what? Let's just do number 2 here. But let's make this slant height. Let's draw a picture. Diameter is 8. Slant height is 12. Volume of a cone is 1/3 pi r squared height. I don't have the height, I have the slant height. When that's the case, I need to do Pythagorean theorem. A squared plus b squared equals c squared. This is half of the diameter, which is 4, so it's 4 squared plus b squared equals 12 squared. 16 plus b squared equals 144, minus 16 minus 16, b squared equals 144 minus 16, 128, square root, radical 128, it's 11 dot dot dot, so 1/3 pi, the radius is 4 squared, the height is 11 dot dot dot, it equals 1/3 pi 4 squared. Second answer. And to the nearest hundredth, I've got 189.56. So you are responsible for finding the volume of a cone given its slant height. If that's the case, you just use Pythagorean theorem. That's all I got. Practice more, practice. Make sure you know your formulas. If you don't, you're going to have a rough day. And that's it. Practice. Have a good day. See ya.